So before I jump into showing you how the execution plan is, how to read the execution plan, I think we can talk about indexes, but it will also make sense if we talk about indexes once we see the execution plan. So I'll log into my server. We'll get into SQL plus /SSDBA. And I think, guys, we had already created a test table yesterday for the locks activity, right? So select, it was describe test_1. Right. This is the table we had created. So what I'll do is I'll quickly show you the execution plan on this, but very straightforward, guys. The execution plan that you're going to see is a very silly and a small one. And trust me, in real time, the execution plans will be very big, and you need kind of like different, you need a separate time to read through all those explain plan. So let me quickly select star from test_1. So we have these different values inside this table. And you can see like ID1 is primary key because we see it as not null. And I remember we created it as a primary key. So now that we know about this table, what you can do is you can quickly specify set auto trace on. So when you issue this command, what happens whenever you execute a query, what Oracle will do is it will show you the output. Can you see? You got all your records, and also it is giving you it will show you the execution plan right on the screen. Now, what exactly do you see over here? So guys, I want to show you guys something. So what I'll do is I'll shut down this database and start the database. There is something I want to show you, very important, and you will understand why I'm doing it once we have the database up. Okay, so the problem with auto trace is you need to commit, otherwise it won't allow you. Shut immediate or commit or rollback, whatever works best. You will understand it in some time why we shut down the database. And then we'll generate the plan again. All right, I'll exit and clear. We'll connect to the database again. Startup. Or what I would do is, guys, just for simplicity purpose, I'll also take a duplicate session. Okay, database is up and running, right? SQL plus /SSDBA. So over here, what I'll do is clear screen. And I'll put this side by side as much as possible. Clear screen. I want to show you something important, all right? So set auto trace on and select star from test_1. All right. Don't worry about this plan for now. Of course, we'll come back to this one. And in the second session, now this is something I'm doing. See, set auto trace on, right? And then select star from test_1. Now compare these statistics and tell me what different did you see over here. It's open for all, anyone can speak.
The consistent reads and then the recursive calls. Then the physical reads. For the first one, the physical reads are more, consistent reads are more, recursive calls are more compared to the second one.
Right. Any other point, guys? I'm looking for an answer from what we have learned as an Oracle database architecture.
The sort memories. For the first one, the sort memory is 0, and the sort memory for the other one is 4.
No, that's not the answer I'm looking.
Physical read?
Actually, in session 1, data dictionary has been read by using recursive calls.
Okay, these are what you're saying, but what I'm saying is, as how you have learned the Oracle database architecture, it has to do something with the instance and the database. Now I gave you a hint.
The first one is reading from physical disk, and the second one is reading from the buffer cache mainly. So it's actually using more memory rather than physical disk.
Perfect. That's the exact answer I was looking at, guys. See, remember I mentioned in the Oracle architecture, first time read, if the SQL is not, or the buffers or the records are not available inside the instance, then Oracle will travel to the disk. Can you see we have physical reads? 6 physical reads happen on the disk, and that's how Oracle was able to pull up these records. And you can see 18 recursive calls were made. And guys, see, right now, again, we can't get into all this to understand what each one of them are. But the point that I want to prove over here is, you can simply look at the physical reads, and over here it's 0. That means if the SQL buffer, if the records are available in the database instance, because the session 1, the user queried the table, and now these records are already available in the memory, then next time when you are selecting from session 2, what Oracle will do is it will avoid the physical reads, and it would get the records output right from the memory, like the RAM. All right, so that's one point I wanted to prove. So what I'll do is I'll quickly close this second one, and we'll jump into the first session to understand the SQL execution plan. So let me clear screen and set lines, triple line, and select star from test_1. Okay, there is something we see as execution plan. All right, we see the records. We have a plan hash value. This is the hash value that has been assigned. So its hash value is again a unique ID given to the plan. So this plan unique ID is this value. All right, and these are the exact access path, like what steps Oracle optimizer thinks it is good in order to get the records out of your table. The way you read the execution plan is from outside in. That means you will have to read from the most indented operation. All right, if you see out of these two, this one is the like most indented one. So if you have a big query, you will have to read the text that is more like indented towards the right side, and then you move to the other text. Like in this case, this is something you have to start reading and then move up the branch. So what you have to do is, when you're reading an execution plan, as I mentioned, things will not be as simple as you see in real time. So let me quickly pull up or give you a sample how things will look in real time, or how bad a plan might be. So we will see something like this. I'm just putting, I'm using the same statements. All right, so this might be like this, and this might be like this, and this might be on this level, and then this might be on this level, like this and this and this. So how do you start reading this execution plan is like rightmost indented lines. You start with these two because these two are indented and the rightmost, and then you read on these two. That means once you're done with these two, then you start understanding these three, because these three are joins. They are joined. That because Oracle considers these three must run in parallel, exactly in the parallel, the same way these two are running. All right, and then you read about these two. That means these might be again join on tables, and then you read the outermost statement. Again, guys, reading the execution plan itself is another science. So we'll come back to the simple execution plan. So in this execution plan, as I mentioned, you have to read from the rightmost indented operation. In this case, you can see what Oracle did was Oracle tried to access the full table, and it will give the name of the object it was trying to access, that is test_1, and then the rows that got impacted due to this read, and then you have the bytes, like 25 bytes of data that was impacted over there, or it was read from the disk. And this is something is important, like cost. And as I mentioned, one of your performance tuning goals is, of course, to reduce the response time, but one of your goal is also to work on the throughput. That means to reduce the CPU, right? So in this case, can you see Oracle calculates its own cost? It's not something like predefined. But what you can do is, like when you have a lot of steps, where is our example? Okay, I deleted. So when you have a lot of steps or a lot of operations, then you see which step is costing you more. There might be one step that is costing you a lot, and then you see, can we reduce the cost by creating an index or modifying the query itself that is coming inside the database, or maybe defragmentation of the data inside the database. A lot of other stuff are there. And then time is what defines exactly as to how much time each operation takes in to execute the query. Now, by looking at this, we can say that it's taking almost like 2 seconds to get the output. So this is the way to generate the execution plan. And guys, like execution plans, this is the simplest one execution plan that you can ever see. I'll show you one other example just to tell you how smart Optimizer is to change the plan based on the requirements. We are accessing the same table, select star from test1. All right, now I'm adding a where clause where ID number. We'll clear the screen, guys. That will be easy, so you will understand. So select star from test_1 where ID number is equal to 1. All right, and I'm hitting enter. Can you see we got this output? We got the record where ID number is 1. Amazing. And now if you start reading the execution plan, this is your execution plan, you can see index unique scan. This is where Oracle is accessing the index that is created on the table. That means the primary key that we have created. So why Oracle is using the primary key this time? Because in the where clause, we are introducing a column that has an index created on it. All right, so that's the ID number 1, and Oracle is smart enough to quickly use the index, and this is the index name. Don't worry, because when you created the table, or when we created the table, we did not assign a name to the primary key, so Oracle gives a name to that index. So this is Oracle given name. You don't have to worry about it. So index, now Oracle, what it is doing, rather than the full table scan, because in the where clause we have a condition where like the ID column has an index created. So Oracle is able to quickly use the index rather than reading all the records and rejecting all the records where ID is not equal to 1. So Oracle definitely will have a lot of plans, but it thinks this one is the better plan. Now, I'll give you another example where you will understand when Oracle will not use the index. Okay. So I'll clear the screen. Sorry.
Arun.
Yes.
Why is there a physical? I can see one physical read.
This is because this time Oracle referred to the index. This index was not in memory, right? So
okay.
it approached to the index, and this time Oracle was looking at the index. So select star from test_1, where now see the magic. Value equal to val1. Okay, before that, let me show you the table data so that you will understand. Select star from test_1. All right, at this time, forget about the execution plan. Just look at this one. In this one, okay, for the val grid that we are looking at the data. Now, we'll try to get this record, but in the where condition, I will use the value column, okay? So guys, be careful, don't get confused. Remember earlier, I have used the query in the where condition. I have used the column that has a primary key index. But this time, I'm using a column in the query, select star from test_1, where value, this is the column I'm using where no index has been created, and I'll give val3 and I'll hit enter. What do you think what has happened over here? Come on, guys.
Data is already
Sorry, can you repeat?
memory, so it data is all memory, so it did not go for 0 physical read.
No. We are not talking about statistics right now. We are looking at the execution plan.
Full table scan.
Right. So that's more important over there. Can you see why Oracle did a full table scan over here? Because the column that
No
we are
index.
the column that we are using in the SQL query, there is no index on the value column, right? So that's the reason Oracle has to go for full table scan. Now the problem with the full table scan, and guys, there is always pros and cons for full table scan, and I'll talk about it in some time once we are done with this example. Now, if you see, it is telling predicate information identified by the operation ID. So for the operation ID number 1, for this table access full, Oracle has applied a filter. Technically, Oracle didn't apply the filter. We told Oracle to give us records where value equal to val3. So this is a good example, like the execution plan right on the screen, you can see the filtration of the data. So that way, many a times, even sometimes it's good to look at the filter data. And like if I mention value not equal to value 3, like male female example I gave, right? So if I'm seeing the user is using a stupid query where filter says gender is not equal to female, then it might become a problem, or gender is not equal to male. And then what I would do is I would quickly analyze the values inside the table and see what percentage of the gender is male, what percentage of the records inside the table are female, and then I can suggest a good option to the application team. So again, guys, our goal for right now was to how to generate an execution plan and how to quickly read it. But there are a lot of other things inside the explain plan, which is out of scope of our session. But I want to show you something that will help the experienced DBAs. So if you just type explain plan over there, generate execution plan in Oracle. So guys, we have two options to generate the execution plan. The auto trace option is the easy one, the one that we have used just now, but there is a big problem with this one. The issue is once you hit enter after giving the command, it will first read the data. It will actually execute the statement and then show you the execution plan. But in real time, when a query is taking a lot of time, you cannot wait for the query to complete and then look at the explain plan or the execution plan, right? See, if a user is saying, hey, this query is taking 55 minutes, then if you use the auto trace option that we are using right now, you will have to wait for 55 minutes to look at the execution plan. Now that's wastage of your time. So what we can do is, first of all, we'll stop the auto trace, set auto trace off. All right. Now, if you run the queries, select star from test_1, it will not show you the execution plan, right? So this auto trace option is good, easy option in case you just want to play around or look at queries that are causing problem. But if a query is really poor, then this is not the good way. Then you need a different method in order to not to run the query, but just look at the plan. So this is where what you do is you just type explain plan for and then type the SQL. Like I'll show you this one. So explain plan for, you type this and then type whatever your SQL command is. Let's take select star from test_1 where value is equal to, we'll go for val4. All right, and hit enter. Now what happened? Explain plan is generated, but this query is not executed against the database. So you don't have to wait inside the database for this query to finish the execution, and then only you will see the explain plan. Not like that. The beauty about this method is you got the execution plan. Now you can happily look at the execution plan. But the question is, how do you look at the execution plan? So you need to run this query. You can simply copy paste it. So select plan table output. Whenever you say explain plan, it will create a plan table, and in the plan table, it will store your execution plan. So whatever the query where you mention explain plan for, the explain plan is stored into the plan table. So when you run this query, dbms xplan is the package that will display the plan output. You can literally copy paste it. You don't need to modify the command. And if you hit enter, can you see you have the plan hash value, you have the execution plan over there, and you also have the filter. But the only problem with this one is, of course, guys, there are ways to display these statistics. Again, there are other packages you can display these statistics separately, but we are right now dealing only with the execution plan. So this method you should use only when a query is very poor and it's taking a lot of time, maybe 20 minutes, 30 minutes to execute, and you want to generate the plan. So at that point of time, use this method so you can quickly look at the plan without executing the command. So guys, a lot of new things inside the execution plan. And one of the important thing was indexes. So what are indexes? And I think a lot of times Sridhar has spoken about indexes and row IDs and then index values. So we will look at what are indexes and all in our, I mean, that's our next topic. So I hope there is no time limit right now. So guys, any doubts for now before I move quickly into explaining you what are indexes, how indexes are related to row IDs?
Yeah, it's a way to force a query to take a particular plan.
That's done through hints. And as I mentioned, I'm not a fan of hints. So I would request you to read about it. And of course, sorry?
Can you spell it? Hence, you could say?
Yeah, that's done through hints. What you can do is you can use SQL hints to force a plan on a query. And as I mentioned earlier, I'm literally not a fan of hints, guys. And even if you have any queries related hints, even if I know the answer, I'll try to avoid it because I have seen a lot of problems with hints in my career. And I actually hate it technically.